our presentation on hardness testing. The goal of this lab was to collect hardness data and compare the hardness and stable aluminum. There are two hardness tests: the Rockwell test that measured its hardness from the depth of an indentation, and the Bernal test that measured the hardness from the width of an indentation. Three materials, steel 1018, steel 1045, and aluminum were tested. Steel 1018 was tested with three different ways: air, oil, and water quenching. Our hypothesis is that water quenching will cause the materials to be harder, and therefore the water quenched steel will be harder. The experiment was done according to the steps provided in the table. Calibration B was done with a ball tip. Calibration C used a diamond tip, and step 7 used a Bernal tester with a 500 kilogram load. The Rockwell tests were done using a Rockwell hardness testing machine. The B test is done with the steel ball with the 980 Newton load for softer materials. The Rockwell C test is done with a diamond tip and a 1471 Newton load for strong materials. We did both tests for water and oil quenched steel and compared the hardness. The bar graph shows the surface level values we found on the dial using the Rockwell test. As you can see, the hardness for water quenching is higher for both B and C tests. The quenching method hardens the material. That being said, comparing unquenched steel and oil quenched steel, we see that quenching is higher. That means that the dial may handle full rotation, so our water and oil values should have an added 100 units. This connection can be seen on the graph to the right. The Bernal test was done using a Bernal hardness testing machine, using a steel ball with a 0.39 inch diameter, or with a 500 kilogram load. A 500 kilogram load was applied, making 3 indents into the aluminum specimen. The indentation in diameter was 0.07 inches. All units were converted to millimeters. Using the shown equation, the hardness was calculated as 199 HP.
So here you can see our average hardness values for each sample. We had to switch from HRB to HRC when we presumed that the HRB values were going over 100 because the gauges we were using only showed the ones and the tens digit, not the hundreds digit. So we know from our data that the water was creating the highest hardness, like our hypothesis said. But you don't really see that in the averages because we had to correct them later on by adding 100. For example, with the 1018 water sample, we got a reading of 7 originally, but we know it was supposed to be 207 because it was the hardest sample after the quenching process. And also the 1018 air quenched, we got a reading of 80 HRB, and it was supposed to be 180. So that's what reflected in the graph and not in the averages that you see on the slide.
Yeah. For our conclusion, so the objective was to determine and compare the hardness value of these two samples. So the quality control possibly used and the material identification use control of material to monitor accuracy and precision, predicting wear resistant, damage resistant. So for verification of it, was added in effect, repeat testing or testing different plants, make sure our metal become more hardened after demonstration, giving insight into structural. So for recommendation, so we use more precise measurement. So environment effect, so environment factors such as temperature, humidity, or corrosion. So we see area for the further research of exploration. So exploration is of treatment effect. So we can analyze a process like quenching and temperature affect metal additives. So thank you for watching our videos. Feel free to do any comment.